If you would recall, we've been learning some shortcuts to differentiation. So we learned some base derivatives like nx to the n minus 1. We learned derivatives of exponential functions. The derivative of a to the x is the natural log of a times a to the x. And we learned some derivatives of trig functions. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of secant is secant tangent. We just have to remember these right now. Right now, our job is just to get to the point where we remember these. Now we want to find some rules for combining those. The way we can combine these functions is through composition. That's when we need the chain rule for the derivative. And we can also combine these functions by multiplying them or dividing them. So these are the cases where we need special rules to calculate derivatives. So remember the structure. We've got some base derivatives. Plus some rules for derivatives of combinations. The ways that we are interested in combining our base derivatives is through composition with the chain rule, through multiplication, product rule, and division, quotient rule. We don't have to worry about with addition and subtraction because the derivative is a linear transformation. So it will respect vector addition. We could just take derivatives a term at a time. We don't need special rules. But when we have a product or a quotient or a composition, we need special rules for finding the derivative. So here they are. If I want to find the derivative of a product of two functions, the derivative of a product of a first function and a second function. And the way that I say it is I say the derivative of the first times the second plus the first times the derivative of the second. So those are the words that I use to remember the product rule. The derivative of the first times the second plus the first times the derivative of the second. I originally just started reading the names and the abbreviations. I just started saying f prime g plus fg prime. That was really great because it even has rhythm to it, and that helps us remember stuff. F prime g plus fg prime. It's not very interesting, but at least you could put a rhythm to it, and that will help you remember it. But then I had a personal issue when they started naming the function f, and I'm like, oh no, that's going to mess me up. And it did, partially because I decided it was going to mess me up, so it messed me up. This is not how we always write the product rule. You might not like this way we write the product rule. You might want to say f prime g. It's always f prime g, but you might say g prime f. Some of you like to go with what the prime first. So f prime g plus fg prime, or f prime g plus g prime f. I don't know what you're going to prefer. At this point, it's a matter of taste. Note that it doesn't matter if we lead with f prime g because this is an addition, and addition is commutative. Notice also that I'm not going to give you the option. I'm not going to write down fg prime as the first term. This is partially because there's a quotient rule, and it needs to lead with the f prime g. But the words that I use, I say the derivative of the first times the second plus the first times the derivative of the second. So those are the words that I will use when I speak the product rule. I say a first, there's a first, and a second. I personally had to get away from using the names of the functions if they happen to match. I ended up in kind of a being John Malkovich situation where the function was called f and the first function was called f. The first in the product was called f. So I usually say the derivative of the first times the second plus the first times the derivative of the second. I'm like writing stuff out half. So those would be the words that I use to describe this. We also have a quotient rule for the derivative of a quotient. So here's how we take the derivatives if we are dividing functions. So a product would be f of x times g of x. A quotient is f of x divided by g of x. Here we say the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So this is going to be a big fraction. So we say the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. There's subtraction here. We can't just rewrite the order. So it leads with f prime g. F prime g minus fg prime all over g squared. If you don't like having the fg and then fg, you can say f prime g minus g prime f. But it's still all over g squared. In this description, I usually separate it out into a top. The words I use are top and bottom. So I'd say the derivative of the top times the bottom minus the top times the derivative of the bottom and then to group those things together, I've built the habit of saying all over the bottom square. I don't know which set of words is going to help you remember the quotient rule. For some of you, it might be none of them. For some of you, it's going to be a top and bottom. For some of you, it's going to be an F and a G. Some of you are going to prefer FG. Some are going to prefer FGGF. I don't know. You have to try them on. You also may note that I usually prefer not using words like all over. In here, it's fairly clear because we're trying to remember something. We're not trying to speak something and say it precisely. But I should lead with the quotient of the difference and the bottom and the square of the denominator. Let's look at an example. Here I have two functions. I got a 5x squared and I've got a cosine x. I've got these two factors and they're multiplied together. We're trying to find the derivative of a product of these two functions. That tells us to use the product rule. So because this is a product, we're going to use the product rule. In the product rule, I have one function that I call the first, and my other function is the second. I need the derivative of the first. I need the derivative of the second. These are the four parts. These are the four parts that we're going to put together into the derivative of the product. We're not usually going to write all these four parts down unless we need to write down these four parts. In the beginning, if you find yourself getting stuck, start writing down explicitly what your first function and your second function are and write the derivatives underneath them or maybe try next to them. I don't know which is going to work for you. We'll give you some options. Now we just start putting together into the product rule. The product rule says do f prime times g, so f prime times g plus f times g prime. I'm going to be careful here, and it's going to write parentheses to indicate that I am multiplying by negative sine x. Just following the product rule. F prime g plus f g prime. The only thing that we don't like about this is I got a plus 5x squared times negative sine x. I don't like times negative sine, so I'm going to take that negative from the sign. I'm going to put it in, I'm just going to make that whole term negative. Positive times negative is negative, so I'm going to write this maybe as 10x times cosine x minus 5x squared sine x. That's just the cleanup. We start by writing down just four distinct parts that go into the product rule, and then we clean it up with our mad algebra skills and our impeccable algebra aesthetic taste. Any questions? How's everybody okay? One of the things that we have to get used to, is the way that we write things in math. We have to be able to read expressions. So notes, we need to be able to distinguish we need to get familiar with the way that we write things in math so that we can distinguish between when we're looking at a product and when we're looking at a composition. So for example, now that we have the product rule, because we are introducing the product rule so close to the time that we introduced the chain rule, and because the way that we're trained on math is very visual, we look at how things are put together. And because of the way that the human mind reads things, reads words, we try to apply those word reading strategies that we have so that we could read things to math. And that never works. Because when you're reading, you're not actually looking at the word. You're predicting what the words are going to be. That's why spelling is kind of a silly thing to be mad about. Especially when you could have just made the language phonetic. But that's another discussion. So we can't just speed read in math. We have to make sure that we carefully read what's going on. So in the first problem, I had a 5x squared cosine x. In the second one, I got the 5 times the cosine of the square of x. The second one is a composition. I see a cosine and an x squared, and it looks like it has the same elements as the first problem. But the way those elements have been combined is very different. So in here, we have a composition. It's not cosine times x squared, because cosine on its own doesn't mean anything. It's not an expression that we can use. It's not a multiplication. This is a composition. The reason I'm pointing this out, even though y'all are thinking, dude, we're familiar with the chain rule. We're experts in the chain rule. We saw it like 3 days ago. So we're experts by now because that's how learning works. You see it one time and you are an expert. That's why I know after having watched the Super Bowl yesterday, all of you can go start as quarterbacks in the NFL. No problem. You've seen it. So now you can do it, right? Isn't that how it works? That's how we all think it works in math, by the way. Math teacher's like, oh, here, just do what I did. That'd be like instruction where Tom Brady's like, oh, well, just do what I did. That's why masterclass is very sketchy to me. It's like, well, I don't doubt that Tom Brady is an excellent quarterback. I do. There is no evidence that he could tell someone else how to be a quarterback. You know what I mean? But anyway. What we have to notice here is that the outside function is the cosine, the inside function is x squared. So we're going to take the derivative of cosine of something. Oops. I put an equal sign here. Shit. Put an equal sign and none of you called me on it. That's minus 1,000 points for everybody. Stubborn. Those two functions aren't equal. So in the second one, we're doing the chain rule. We see the same elements, a square and a cosine, but we're going to put them together differently. The derivative of 5 times the cosine of something is 5 times negative sine of that thing. Times the derivative of that thing. And we would, as usual, want to clean this up. There's a 5, a negative, and a 2. That's all negative 10. There's an x, that's the polynomial. We should write that first. Our goal, since we need to mention it, our goal is to not always write this before we write the answer. Our goal is to skip this and write the answer. The goal of doing the math in a math class is to not have to do the math anymore. That's the goal. The goal is not to write all this stuff in the middle. The goal is to write down the answer, to know how it's going to work. I think every calculus teacher does this example when they do the quotient rule. So very typical on my part. Apparently, Brittany and Justin want to be. I don't have enough hair to flip around anymore. So tangent, it can be written as a quotient, as sine over cosine. We can write tangent as sine over cosine. So we can use the quotient rule. We'll take the derivative of the top. So breaking it down into parts, the top is sine x, and the derivative of the top is cosine x. The bottom is cosine x, and the derivative of the bottom is negative sine x. So the quotient rule says do the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the square of the denominator. Here it is, just putting things into the 5 spots in the quotient rule. The top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. Now, of course, we want to clean it up using our mad algebra skills. Cosine times cosine is cosine squared. Sine times negative sine is negative sine squared times a negative is a plus sine squared. And the denominator is going to be a cosine squared. And now we're going to remember our trig identities. Cosine squared plus sine squared is 1. And so this is equal to 1 over cosine squared. And 1 over cosine squared is secant squared. We want to make sure that all the new information that we come across still fits with our old information. So now I verify a little bit that derivative of tangent is secant squared. Ultimately, if you didn't believe me the first time around, you probably still don't believe me now because, well, maybe you're just being sketchy about the quotient rule. I mean, I can't fix that if you're not going to trust me. We'll just be super suspicious. Remember that these rules are a reading exercise. You have to look at how the functions are being combined, and you have to so that you'll know which rule to apply. We can't just look at things visually anymore. We have to be able to read what's going on. We can't apply hooked-on phonics to math because we write things very similarly, but we mean very different things. The written language in math is very precise. The reason it's more difficult is that we can get around a lot when we're just trying to read written communication or spoken communication. Think about the range of words that you can hear and the range of ways you've heard that word and still knew what that word was. Mostly because you're not hearing the words, you're hearing the sentence, you're hearing the thought, you're hearing the idea, and you're using more than just the words to decide what's going on. You're using the context, what you know about the other person, how the words sound. That's probably least important. Think about when things are written. You don't really need everything to be written precisely to get the exact same sentence across. It could be spelled wrong, the words can have typos all over the place, and you still see the message. In math, no. We have to write it a particular way. That's why everybody's mad in math class all the time. It's like, oh, you know what I meant. And sometimes I know what you meant, and I have to act like I didn't know what you meant because you didn't write it correctly. And it's not about whether you knew what you meant. It's about whether you knew what you meant, number one, and number two, whether you were able to communicate that you knew what you meant to some other person. That makes sense? That's why you're going to be mad at me all the time. Taking off points just because your answers are wrong. What a jerk. How's everybody okay? And you're like, oh, no, you just explained it. We're all mad at you because you're the math teacher. Pay attention, man. I have some chain rule problems for you. It's just 6 problems, chain rule. We're not going to break into groups, but you can help each other. I recommend that you do.